So guys, I don't really know how many of you guys use Kubernetes or Docker for that matter. So this is going to be a pretty unstructured talk. We're going to maybe do some hacking on some things. We got a couple of clusters sitting around. And we can kind of go as deep or as shallow as you guys want. But can you guys give me a show of hands as far as how many people are running Kubernetes in production? Containers, microservices, any of that? Okay. Yeah, you guys, okay. Rob and Randy over there. Okay. So what about for dev? How many of you guys use Docker to build stuff? Okay. So we got a few people. All right, cool. All right, anybody using Swarm or Mesos? Anything? No? Nobody uses, okay. Nobody using that, okay. I guess Kubernetes took over. So yeah, I'm Jay. I know some of you guys. I've been doing stuff in the ASF for a while, and I work on Kubernetes upstream as well. Well, I work at a company called Platform 9, and we provide a managed Kubernetes offering. And I've been in the Kubernetes space since Epoch, like doing stuff in upstream and whatnot over at Red Hat. And I did want to take an opportunity to say thanks to the ASF. This is where I started my open source kind of career a long time ago, working on BigTop and hadoop and stuff like that. And this is it's a great foundation. So this is my information, Twitter, email, whatever, Platform 9 stuff, if you guys are interested in managed Kubernetes. And of course, most important of all, kubernetes.io, it's our community. You know, we got our own foundation like the CNCF, just like the ASF. And so, like I said, yeah, just interrupt me anytime if you guys want to dive into anything. And I'm just going to kind of start going through some stuff. Basically, so threat modeling, right? Well, the reason it's important is, especially in a distributed system, there are so many problems that you could have in terms of security that there's no clear place to start. And you can always make things more secure and harder to use and slow people down and make people's lives miserable. So before you do all that, the best thing to do is actually figure out what you care about, prioritize things, and figure out in terms of, the model for how people might attack you and what you need to make safe, what data is important, what data is not important, what trade-offs you're willing to make, right? Because that's what engineering is, all just a bunch of trade-offs. And you're just making one crappy trade-off for something else, right? So, so a couple of quotes. HTTPS is the universal firewall bypass protocol. So how many of you guys have heard of a company called Twistlock? Okay, so yeah, so the idea here is that the first, I think, most important thing to take into account is old school IT policies, castle walls. IT just doesn't work in a Kubernetes environment because everybody's doing everything on port 443, and that's where and so that port's open and everything else is closed, and so you really haven't changed anything by locking down ports, and it gets worse than that, and so it gets worse than that because if you look at an IP tables trace inside of Kubernetes, you'll see hundreds and hundreds of rules. You could see 10 new IP tables rules or something like that for a given service, right? And so, and IP tables rules are always changing and whatnot. So the basic network security stuff that you used to do isn't really super useful in a Kubernetes cluster and actually will break things. So you have to start thinking about security differently, which is where the second quote comes in, which is from one of the PMs at Google. Security at scale has to be transparent to applications, right? So, that's where service meshes and things like that come into play. Okay, so I will show you guys what a managed Kubernetes offering looks like. We're not going to spend too much time on this, but this is how we do it over at Platform 9. The nice thing about it is you don't have to worry about any of this stuff if you're paying somebody to do Kubernetes for you. Right? We patch for you, we update stuff for you, and we run it all on your own hardware. And there's a lot of other, Kubernetes distributions out there other than us that'll do the same thing, and sometimes that's the easiest way to go. But I would never discourage anybody from hacking together their own Kubernetes cluster and trying to keep it secure and trying to maintain it, trying to do all that. You'll learn a lot, for sure. TLDR, before I dive into other stuff, there's, 90% of the stuff here, you guys could just go read it for yourself. There's a great article. The best one, if you had 20 minutes, is 11 Ways Not to Get Hacked. It's on the Kubernetes IO blog. The other stuff is RBAC. Just go read the RBAC docs. Those are if you just understand those two things, you're probably 75% of the way there in terms of having a cluster that's reasonably secure. So, all right, now let's look at when you're paying somebody for a Kubernetes distribution, what are they doing like when they patch stuff, right? Because patching is, how many of you guys have had to like do a CVE patch for something, like in a production system? Okay. So, yeah, a lot of people, it's good we have a few people that have done it here, but a lot of people have never had to do anything like that. It's actually not that complicated. So, I'm gonna switch mics. Does this one work? All right, yeah. So it's not that complicated. So this repo is on GitHub, and I have a whole bunch of snippets, shell scripts and stuff. So this presentation is going to be something you can play with on your own. So the first one, I'm just going to show you roughly what it looks like to patch the most recent CVE. So do you guys hear about the recent Kubernetes CVE? Does anybody know what it was? Okay. So yeah, involved. Basically, it involved runc. So how many of you guys know what runc is? Okay, Rob knows. Anybody else? All the Kubernetes people, the 2 Kubernetes people, come on. Okay, runc, everybody, you guys got to know this. So Docker, right, just depends on runc under the hood, right? That's at the basis of it. Now, any container runtime you've got, whether even if you're running cryo, you're still firing off commands to runc. Now runc is it's a small binary, and actually the patch for this CVE was you could literally just copy in a different runc, and then you're secure. You don't even have to reinstall Docker. You don't have to do anything. And the reason is because the well, thanks to Rancher for this, because they actually curate a repository with patched runc, right? So if there's something wrong with runc, your Docker's running, runc doesn't change so much that it's going to break Docker, right? And so, so that's the easiest way to patch it. So that's really all a patch looks like, right? Literally, sometimes it's just literally a matter of copying a binary. And so when you're installing Docker, runc's brought in through a different package like CentOS or Ubuntu, and managed that way. This would have been, you wouldn't have had this problem if you had PSPs, pod security policies, you weren't allowed to run things as root. It wouldn't have even caused a problem for you. So pod security policies are in beta, but a lot of people are using them. I think you get them for free in GKE. As I recall, I think OpenShift has them. You can enable on our platform as well. And pod security policies are really nice because they kind of like disallow everything by default. So if you're one of those people that really wants to be secure, just disallow everything by default and then force yourself to use PSPs. Yeah, exactly. You have nothing, right? You can't do anything, right? It's totally useless, and you have to enable stuff. So I mean, I think we should just detour because I have somewhere on here like an example of that, of what it looks like to enable PSPs. Where are they? Well, probably lost it. Well, anyways, I'm not going to bother. But yeah, you're right. You can't do anything. Totally secure. So, and you enable things one by one. There's a very nice declarative way of defining what you want pods to be able to do. I mean, it's SE Linux. It's do you want them to be able to run privileged stuff like that? It's very intuitive, and it's all declarative in Kubernetes. So again, Bo, so just to kind of jump back up again, and talk about why you again have to think about like what you actually care about before you just start making things secure, like you said, because you want to be able to run your programs, you want to be able to make money and sell software. There's IP table rules, like that scales O of services, right? So the more services you have, it's actually O of services times pods, right? The more services you have in a Kubernetes cluster, the more rules you're going to have in your network. You can't go just changing stuff. We already talked about that. Network policy versus having multiple clusters. Like, you could sit there and make the most complicated, ridiculous network policy, make everybody's life miserable, have a bunch of meetings, or you could just have a second cluster for stuff that you think should be like easier to run. And so like, don't feel like you need to make a really complicated like solution to something that just requires a different cluster. People have been doing that kind of security for a very long time, and it works, right? Different hardware. Vanity SSL versus like certificate chains and rotation and expiration, right? Everything's SSL nowadays. Everything's certificates. The problem is most people implement SSL. They don't actually implement any real security around it. So it's just a vanity thing, right? You've got these certs. You never rotate them. If they ever get compromised, you don't even know whether you're secure or not, or how often you're expiring your certs. So you have to think about that. And so this is what threat modeling is, right? You come up with a model of security that you actually care about, prioritize things, focus on the things that are important. So I will give you an example of the IP table stuff. I think I have Minikube running. So we don't have any super adventurous demos here, but so if I do, so the way you list IP tables -L does not list, what's that? Zoom in? Yeah, look better? Okay. So IP tables -L doesn't list everything. I don't know why, it just doesn't. So, but there is a way to list everything, which is you do, I mean, it does list everything, it's just in like one of the chains. It's in like a specific change. But if you list everything that's in NAT, right? Oops. Right? You could see first of all how long it's taking, right? And I WC-L this, I'm just gonna count how many rules there are. You're gonna see there's 158 rules, right? This is a Minikube cluster. There's hardly any services running, right? And if I was to remove one of the services, I'd have 148, right? So that's by default how complicated the networking model is when you get started. Another thing to think about in terms of like kind of like old school security is like scanning stuff, right? You scan something, use static code analysis. Some code is making a call to exec or something. Like think about something like Apache HTTPD, right? So like that's got to exec, right? That's how that's how a huge part of how HTTP works. And there's actually so there's actually a lot of things that your program may be doing that's totally valid that your static code analysis is going to complain about. So again, you have to model your threats, decide what you care about, what you don't care about, what's important, what's not. And there's no out-of-the-box tool that's just going to make everything work for you and give you the ideal security model, right? Okay, so first, do no harm, right? Like don't blow up the world just because you find just because you feel like you're not secure enough. Figure out what's wrong. Like we already said, you could pay somebody to do this. How many of you guys have heard of service mesh technology? Okay, so yeah, service mesh, I know this sounds like kind of hype, but the fact is it's probably the solution to everything. Like, it's just like, that's kind of where everything's going, because the fact is you just can't tell programmers what to do. They don't listen, right? So the only way to manage this problem is to have a systematic way that you can allow people to write code, be creative, build things, and that you can control the way that those things communicate in a systematic, higher level way, which is kind of just an extension of what you're already doing when you adopt a Kubernetes environment, right? You're telling people to talk over ports. You're telling people they have to actually build these things called containers. They can't just have random dependencies floating around. So it's just an extension of that, where you're constraining the amount of potential problems they can have, and you have a systematic way of kind of commoditizing the solution to it. So once you start, okay, so now you've got Istio, that's a solution. But okay, as you start to secure your cluster in other ways, because what you need to do is like come up with a workflow that will scale over time, right? So there are these things called conformance tests in Kubernetes. Have any of you guys ever, for those of you running Kubernetes, have any of you guys ever run or used the conformance tests? No, okay. So do any of you guys know what they are? Have you heard of them? Have you heard of a company called Heptio? They got bought for like a ridiculous amount of money recently by VMware. Okay, so they made a tool called the Sonobui Scanner, and it is basically a really nice high-level interface to the Kubernetes end-to-end tests. And Kubernetes has the best end-to-end testing that I've ever seen in any distributed system that's the most well-maintained by the largest community. It's incredible. And it gives you it's very easy to run. The directions are right here, and every single managed Kubernetes, every single certified Kubernetes distribution, right, posts their results of the conformance tests on GitHub, right? So you can see them. So for example, and the end-to-end tests look something like this. Where did I put them? E2E logs, right? I just had 4 of them because I didn't want to clutter the whole screen. But like each one of these, you can grep through them, and you can you literally send a flag in, and you could say like, I want to test for resource quota. Make sure I didn't break that. Make sure volumes still work. Make sure networking still works. So there's a regular expression. You can run these tests, and every time you change something to lock down your cluster more based on a vulnerability you found, you can run these tests and know that you didn't break Kubernetes. So just so that it's clear here, there's about 130 of them, and really the definition of what a Kubernetes cluster is, does anybody want to take a guess? What's a Kubernetes cluster? It's something that passes the conformance tests. That's all it is, right? So if you pass these conformance tests, then you're a Kubernetes cluster, and you're guaranteed that your application will run anywhere, right? So Kubernetes is not defined by the scheduler or the controller manager or even etcd or any of those things. It's defined as an API, right? And as a cloud API, right? So that's all you have to do. So as much as it sucks to have to lock down a system and secure it, and how hard it is, really there's no better platform to have to do it on than Kubernetes. Like imagine trying to do this in a Hadoop cluster or a Spark cluster or a Mesos. Like where would you start in terms of knowing whether you broke things? If there's anybody that knows how to do that in any of those platforms, let me know. I mean, this isn't ApacheCon, so I don't know. But I wouldn't know how to do those things. There are some great Hadoop tests out there, but I don't know if there's anything comprehensive that's modular that way. Okay, so I will show you guys, this is probably not something that you guys are going to ever want to do in the audience, but I'm going to show just a quick snippet of how you run the end-to-end tests from source, right? So literally the command to run a test that makes sure you didn't break Kubernetes secrets is as easy as running kubetest --test, then at these test arguments, provider skeleton, which means that you're not doing anything cloud specific, and boom, it'll just run. In order to build them from source, you just have to do, basically do this. And this is literally everything. Cloning it down, checking a branch out, everything else. So this is kind of how I do it. I'm not going to run it right now because it takes forever to compile. The thing that takes a long time is compiling Kubernetes. And you always have to run the tests on the same version of Kubernetes on the client that runs on the server. So, yeah. All right. So, here's what you might have broke. API server, etcd, kubelet, secrets, network, the daemon sets that are running in your network, volumes, empty DIRs, volume permissions. That's always a really easy thing to break, especially if you, like, for example, you're turning on SE Linux or whatever. You want to make sure that people can still mount storage. Ephemeral storage especially is important because ephemeral storage is where all your service accounts and your secrets and all that stuff go. So if that's not working, your pods aren't going to be, they're not going to be able to do the most basic things like talk to the API server, which is very common, right? That for to write a pod nowadays that does some minimal amount of communication possibly with the API server. There's, the ability to, just be able to store a secret, right, to access a database. Like, you've got to have empty dir working for a production Kubernetes cluster. Like, otherwise you won't be able to do anything, even if you're not storing persistent data in there. So, application security. So far, we've talked about Kubernetes itself, right? And we'll get back into Kubernetes itself, but because this is not the longest talk, I just wanted to make sure I got breadth first, right? So, application security. How many of you guys have heard of Black Duck? Okay, the Black Duck people over there, right? Okay, so there's Black Duck. There's a CoreOS. How many of you guys have heard of CoreOS? CoreOS? It got bought by Red Hat, right? So they got this great tool called Claire. A lot of us here came from Black Duck, and we have some tools also at Black Duck. Got acquired by Synopsys. one of the cloud native products that's based on the hub, the Black Duck hub product, was a thing called OpSite, which I worked on for a while. That's another container native kind of scanning solution for application level security. We already talked about Twistlock, totally different paradigms, right? So what's really cool about Twistlock is they look for anomalies in your apps, right? So something binds to a socket, something's writing data to a directory it never wrote to. So it looks at, I mean, it really embraces this new model for security where you're not locking things down and you're not being intrusive, and instead you're building stuff that's smart. The other scanning, the other application type solutions that are out there, I mean, there's so many. I just picked 3 that I kind of knew about. Black Duck will scan stuff at very high granularity. It'll give you a big UI that gives you, the ability to browse through different like CVEs and figure out which ones you care about and which ones you don't. It'll scan everything that's actually there on your content. Claire is fast, so Black Duck can take a long time because it's doing that. Claire is fast. It's caching stuff. It looks at Docker layers. And we could actually scan something if we have time with Claire, and you could just see the see the vulnerabilities in Airflow, right? Like, or any other Apache project for that, or the potential vulnerabilities. Because again, when you're doing these scanning for CVEs, it's really hard to extract the signal from the noise. There's a lot of false positives. But anyways, that's the application level, right? So far we've talked about Kubernetes, and we've talked about the way that Kubernetes security sort of surfaces in your day-to-day life, and then there's the whole application stuff, and Kubernetes security isn't going to help you with your application. If you have some application that does something stupid that exposes a service to the outside world, no matter how secure your Kubernetes cluster is, your application is running on that cluster, and especially if it's running as root, it could cause all sorts of damage. And even if it's not running as root, there's cluster role bindings and RBAC, and that's the other huge thing that you have to understand. So how many of you guys have used some kind of RBAC before, like LDAP or whatever, anything? I mean, like, you understand the basic concepts of, obviously. So now, how many folks in the audience have used Kubernetes RBAC or had to do anything with Kubernetes RBAC? Okay. So does anybody want to volunteer? What's the most annoying thing you had to do with RBAC? What was your solution? Like, no? Yeah, what's the worst thing that you wouldn't want? Did you just cluster admin? Did you just make everybody cluster?
I don't want to end up just rolling through
One by one, exactly. So, okay, so if you're doing one by one, there's a reason you were doing that. You're probably doing it pre-audit, right? So now we've got audit logs, right? So I'm going to show you how to solve that problem later. In SE Linux, they used to have the same problem too, right? You'd have these AVCs, and you run something. So like the first time I ran into an AVC problem, I was actually working at Red Hat at the time, and I didn't want to learn how SE Linux worked, so I went over and I asked Dan Walsh, who the SE Linux guy, to fix the problem for me. And he went and he just looked in the AVC logs, and he said, you just need to copy paste this and fix it. And that's what you have to do in Kubernetes up until recently, when Jordan Liggett basically made this tool that's called, like, in SE Linux, it was called like audit to allow or something, and he made this tool called audit to RBAC or something. And so you just basically trail the audit logs in Kubernetes, which are also a really important thing for security in general, because you can see what's not being allowed by the API server. And it will just spit out RBAC that would allow an API call that was otherwise rejected to get accepted, okay? So I probably should have explained what RBAC was before I started talking about this. RBAC is just a way of saying this person can do this thing to this resource. That's all it is, right? It's nothing other than that. And so Kubernetes is just, again, it's just an API, so it's just resources. And all it is you doing stuff to resources. That's all. When you're doing Kubernetes, that's all you're doing. You're just doing stuff to resources. So for example, you're creating a config map. You're editing a config map. You're deleting a config map. You're creating a pod. You're creating a deployment. Then that deployment goes off and it creates pods. Like, everybody's just, it's the same set of primitives, right? Like warning signs. So I think it's probably, in the interest of time, I think we should I should probably show you how to use KubeHunter, because that's probably something that you guys are going to want to look at. So KubeHunter, where is it? Let's see. I like put notes in here, and then I don't like read my own note. Okay, KubeHunter, there it is. Yeah. So these are like shell scripts that like I've sort of written to be played with and read, not necessarily just run, right? So I'm just going to Vim this guy and take a look here. So yeah, KubeHunter is great because I can run this on any cluster, right? And all I have to do is I have visual mode in Vim. Visual mode's the worst thing. Okay, so all I have to do is, like, I'm gonna just jump into a mini kube cluster, right? And you can do this on a production cluster too, you can do this anywhere. All you gotta do is jump into your cluster, right? And then just run this Docker command, okay? And then what it's going to do is it's going to say, okay, what do you want to what do you want to scan? So it's going to like pen test your cluster. Okay, 2 minutes. It's going to pen test, right? So now I just put in. This is kind of stupid, but obviously in the real world you wouldn't. Well, you would. You maybe do this on your API server. That's the best place to do. Well, you know, or any other node in your cluster, or every node in your cluster. I'm just going to run. You know, I just did loop back because I'm SSH'd into my cluster and I'm SSH'd into a node that's running a kubelet on my cluster. And this is a very common vulnerability to have, which is that your kubelet is exposing traffic locally, is exposing all sorts of stuff locally. So the kubelet has its own API. And the reason it has an API, does anybody want to guess why the kubelet has a REST API? No, but that maybe it might be useful for that. But the reason is because you have to be able to access things like logs. You have to do execs. Like you have to access stuff from the kubelet if you're the API server. So there's not a lot of stuff you do, and another one is metrics. And this is what and so you can secure that endpoint with TLS. But if you don't, and so you can secure it. But the thing is, if you don't secure it, which is like, you know, a lot of distributions just don't secure it, then it's just sitting there exposing a whole bunch of pod stuff on your cluster. You'll be able to see you'll be able to basically see everything that's running in your cluster. You'll be able to get all sorts of like metrics related information and stuff. So, you know, in a real Kubernetes cluster, you're probably going to want to lock that down. But the nice thing about KubeHunter is this tool that came from Aqua. I think Liz Rice either wrote it or helped write it or something. But it's this great tool that'll just pen test your cluster, and you can just run it anywhere, and it'll work on any Kubernetes cluster, and it'll probably give you something useful. So that's KubeHunter. Again, really easy to run. Don't need anything fancy. You can also run it as a pod. You can run it as a job. There's different ways to run it. I just like to do it by SSHing into the nodes. And so I think with 2 minutes left, I think we're kind of right at the end. Oh yeah, so I did want to talk a little bit about Black Duck's offsite product because it's a totally different paradigm than the other ones, which is that it's constantly monitoring what's in your cluster and then it's scanning it. And it's actually scanning it like for real scanning it, like scanning the actual contents of every application, every container, right? So you could build your own, you know, like you could build your own thing that was like offsite that did that pretty easily. So if I go to JSON. I might have a nice snippet in my history that I can steal. Yeah, here we go, right? So you can just very easily, using Kube API, just go ahead and grab all the images. These are all the images that are currently running in my cluster, right? So I could just grab those, and I could just do this. If I put a watch around this, okay, I now have the ability to continuously, like, get a list of images that are currently running in my cluster or enabled in my cluster in some way in a pod. and I could just scan those one at a time, however I wanted to, make a scan queue out of it. The Black Duck offsite product, which is totally open source based on a thing called Perceptor that we built, is an infinite scan queue that manages all this, creates a work queue for you, makes sure that it does back off if scans take a long time, because it can take, for a gigabyte, container, it could take a minute, 2 minutes, 10 minutes to scan the entire thing, depending on how much other load there is on the cluster. So it does things like it'll do a back off, it'll circuit break, and make sure that over time it scans everything in your cluster. It's a very heavyweight solution, but over time, as that platform becomes faster, it could be a very nice way of kind of automating fine-grained CVE kind of analysis in your clusters. I think I'm out of time. Is that correct?
You got like 2 more minutes for questions.
I got 2 more minutes for questions. Okay, cool. Yeah. All right. So if there's any questions, I can take them now. If not, I think just want to make sure I show. Okay. I actually have one more thing I could show you guys if there's no questions. The difference between good RBAC and bad RBAC. So this is a role. This is a role that gives you the ability to modify this one resource and to get it, or actually not even to modify it. If you see something like this, it's probably bad, right? If you've given somebody star properties on everything. And also another myth is that you need to give Helm God properties. That's not really the case. You can run Helm so that it only works in a given namespace. So for those of you people that use Helm, you can give it a role like this, and this is a really easy solution to the problem of not wanting to have Helm be able to just take over your entire cluster, and it could just manage resources in a given namespace. So that's pretty much it.